Hello, today we are going to learn IoT standards interoperability in IoT. In Module 5, we have these topics: IoT standards, IoT, COPE, OPC-UA, and others, IoT interoperability, device-to-device, device-to-platform, and platform-to-platform, IoT testing and certification, conformance, interoperability, and security. There are several standards that have been developed for IoT communications and interoperability, including 1. IoT Message Queuing Telemetry Transport. IoT is a lightweight messaging protocol that is commonly used for IoT applications. It is designed for low bandwidth, high latency networks and is often used for applications such as remote monitoring and control. 2. COPE Constrained Application Protocol. COPE is a lightweight protocol that is designed for use in constrained networks, such as those found in IoT devices. It is designed to be simple and efficient and supports a range of IoT-specific features such as multicast communication. 3. OPC-UA Open Platform Communications Unified Architecture. OPC-UA is a machine-to-machine communication protocol that is used in industrial automation and other IoT applications. It is designed for use in complex, heterogeneous environments and supports a range of features for secure communication and data exchange. 4. Loom-2M Lightweight M2M. Loom-2M is a protocol that is designed for managing IoT devices and their associated data. It is designed to be lightweight and efficient and supports a range of features for remote management and firmware updates. 5. Zigbee. Zigbee is a wireless communication protocol that is designed for use in low-power IoT devices. It is commonly used in applications such as home automation and smart lighting and supports a range of features for secure communication and data exchange. These standards provide a range of features and capabilities for IoT communication and interoperability. They can be used to build complex IoT applications and devices that are secure, efficient, and reliable. IoT interoperability refers to the ability of different IoT devices, platforms, and systems to communicate and exchange data with each other. There are three main types of interoperability in IoT. 1. Device-to-device interoperability. This refers to the ability of different IoT devices to communicate and exchange data with each other. For example, a smart thermostat and a smart lighting system might communicate with each other to adjust the temperature and lighting in a room based on occupancy. 2. Device-to-platform interoperability. This refers to the ability of IoT devices to communicate with an IoT platform or service. For example, a smart home security system might communicate with a cloud-based platform to send alerts and receive commands. 3. Platform-to-platform interoperability. This refers to the ability of different IoT platforms to communicate and exchange data with each other. For example, an industrial automation platform might communicate with an energy management platform to optimize energy usage in a manufacturing facility. Interoperability is critical for the success of IoT applications and devices. Without interoperability, IoT systems can become fragmented and siloed, making it difficult to integrate and scale different devices and platforms. To achieve interoperability, IoT standards such as IoT, COPE, and OPC-UA can be used to enable seamless communication and data exchange between different devices and platforms. IoT testing and certification are crucial for ensuring that IoT devices and systems are functional, interoperable, and secure. There are three main types of IoT testing and certification. 1. Conformance testing. This type of testing verifies that an IoT device or system conforms to a specific standard or specification. Conformance testing ensures that devices and systems work as intended and can interoperate with other devices and systems. 2. Interoperability testing. This type of testing verifies that different IoT devices and systems can communicate and exchange data with each other. Interoperability testing is essential for ensuring that IoT systems are scalable and can work together seamlessly. 3. Security testing and certification. This type of testing verifies that IoT devices and systems are secure and can protect sensitive data and information from cyber threats. Security testing and certification are essential for protecting against data breaches, cyber attacks, and other security risks. IoT testing and certification can be performed by various organizations, including standards bodies, testing labs, and certification bodies. For example, the Open Connectivity Foundation (OCF) provides conformance and interoperability testing for IoT devices, while organizations like Underwriters Laboratories UL provide security testing and certification for IoT devices and systems. By ensuring that IoT devices and systems are tested and certified, manufacturers can provide assurances to their customers that their products are reliable, interoperable, and secure. This, in turn, can increase consumer confidence in IoT technologies and drive wider adoption of these systems. Thank you for watching us.